Hello students, today we are going to see some more interesting point, that is one among coordination compounds naming ceremony, that is a nomenclature of coordination complex compound. Actually it's very interesting and easier, and already you have gone through organic nomenclature IUPAC name. The same idea, there are some rules and regulations are there. If you know correctly that rules and regulations, you are able to name the coordination complex compound. Come on, let us go and identify what are the rules are there, and along with that example then we'll go for that naming ceremony of coordination complex compound. The first one, the name of the complex compound should not start with capital letter. Usually always we will start with capital letter whatever it is, but coordination compound exceptional, so you are not supposed to start with the capital letter. And one more point, the full name of the coordination sphere is written in one word. I hope you remember what do you mean by coordination sphere. So that one, now for example, K4FECN6. Okay, so this is coordination sphere. This part which is called coordination sphere, cs I put it. So this coordination compound, while naming, the full name of the coordination sphere is written in one word. How come to say that one word? Potassium ferrocyanide. Potassium, there is a gap, and ferrocyanide. See, potassium ferro ferrocyanide. Okay, see, there is a gap in between, there is a gap, and ferrocyanide, one word only, there is no gap in between. Here two words are there, ferrocyanide, but you are not supposed to leave any gap. Ferrocyanide, because what is the rule? Coordination sphere is written in one word. Okay, now let us go for the next one more point. And ionic complexes contain two parts. So what are those two parts? Coordination sphere, ionic sphere. See that? Coordination sphere, ionic sphere. Coordination sphere, you know very well, this is the coordination sphere, and ionic sphere. As we come to those two parts only, out of these two parts, cationic part named first. See, same example we can take it. Cation, anion. K4, K, potassium, it's a cation. So cation named first, and then anion part with the gap. So there is a gap in between. I hope you got an idea of the second rule. So ionic complexes contain two parts. One it is coordination sphere, the other one it is ionic sphere. See, whenever you are seeing that naming that coordination compound complexes, you won't feel complex. It is so simple if you know the rules, right? Okay, the same idea only, I just bring it to you. So those two parts, which one shall come first, the which one the second one? The first one, it is what it is, cationic part. So which is a cationic part? Potassium, it's a cationic part, and then there is a gap in between, and then anionic part. Of course this is an anionic part. Cyanide, it is an anionic part. Ligand, one who is donating pair of electrons to the central metal ion, right? That is only. I hope you got a clear idea about this point. Now the third one, the ligands are named in alphabetical order before the name of the central metal ion or atom. For this rule, I brought this example. Potassium is there, that is a counter ion. Chromium, it's a central metal atom or ion. Carbonate, CO3, twice it is there. And ammonia. See, these two are ligands. That is what it has mentioned. The ligands are named in alphabetical order. So, two ligands are there. So, that means whom you have to give preference. So, that means alphabetical order you have to name. So, in alphabetical order before the name of the central metal atom or ion. So, that means you have to give the name according to the alphabetical order. The central metal ion, after that, end of that, you have to write it. Okay, now come on, let us go for the first one, cationic part. So what is it, cationic part here? Potassium, there should not be no capital, and there should be a gap in between. Then diamine, dicarbonato chromate. So diamine, A for first, carbonato, C for that next. Okay, diamine amine dicarbonato. That then there is no gap in between. One word only. They mentioned one word, no? So that is diamine dicarbonato, carbonato, chromate, chromate. Okay, hope you got a clear idea. Potassium, diamine, dicarbonato, chromate. There is no space. I just bring it here for to write, but there is no gap. Chromate, chromate here three. That three I will tell you later. According to the rule, I'll give the example. What are the things has to be done? Okay, hope you're clear. Okay, now that here one more bracket word it has mentioned. What it is? This procedure is reversed from writing the formula. So, writing the formula is written from the writing name. See, writing the formula, what it is? Potassium and central metal atom chromium and carbonate. Carbonate, as we are writing first, amine, that is amino compound, ammonia, we are writing the next. But here, according to the alphabetical order, potassium diamine, dicarbonato, chromate. So, while writing the formula, you are writing carbonate first and ammonia next. Whereas while naming that compound, that complex ion, you have to give alphabetical order. Hope you're clear with this third point. Okay, now let us go to the next point. The next point, names of the neutral complexes are written in one word. Now, here they mention very clearly names of the metal atom or ion in cationic or neutral complexes remains the same. Example, iron, tin, copper, silver and gold remains the same, don't change in Latin. See, I'll give one example here. FeCO 5 times coordination sphere. How can you name that? Actually, here there is no gap in between, neither no capital letter. So, what is the name of it? This is pentacarbonyl ion. Penta, pentacarbonyl ion. Okay, so there is only one name. There is no gap in between. One word this is. Okay. Now, the next point, names of the anionic ligands end in O. Anion, you know very well, chloro, bromo. So, in that way, here they mentioned very clearly. So, anionic ligands end in O, and those of the neutral cationic ligands are same. Neutral cationic ligands are same as they mentioned very clearly here, except water. Water, it is a neutral, no? So aqua for water, amine for ammonia, CO for carbonyl, NO for nitrosyl. So these are all you should give special name for it. NO for nitrosyl, CO for carbonyl. CO, you just see how it has written. CO, this CO which is different, this CO which is different. That is cobalt. But this is carbonyl. You please think of in that way. Okay, now next one, what it is? Amine, for ammonia. Okay, now the next one here. Anionic complexes. So these are all anionic complexes. How do we name that? Here, chloro for chlorido, chlorido, bromo, bromido, and nitrite, nitrido, and this is chlorato, and this is, yeah, this is nitrato, and this is hydroxido. Okay, I just mentioned capital, but there is no capital. Remember that. This is cyanido. Okay, this is amido. This is amine, double M, but this is amido. And this is imido, NH2 minus, NH2 minus. You see that? NH2 minus means amido, NH2 minus means imido. Okay, now this is sulfato. sulfato. See, SO4 2 minus sulfate, sulfato. Then this is O2 2 minus this peroxido. Peroxido. This is O2 minus oxido. Oxido. See, simple, simple. Only you should know the logic. Okay. O2, it's a peroxido. O2 2 minus peroxido. This is O2 minus oxido. This is acetato. CH3COO minus, it is acetato. Acetato. Okay. Now this is thiocyanato. Thiocyanato. And this is isothiocyanato. Isothiocyanato. See, you see that. SCN, just ulta. Okay, now this is hydrido, but this is hydroxido. OH minus, it is hydroxido. But here, this is H minus. Hydrido. Hydrido. Okay, now this is carbonato. Carbonato. Okay, I hope you got a clear idea. And one more thing, NH2 minus amido, NH2 minus amido, NH3, it's a neutral complexes, amine double M should be there. Please remember all these small tricks. Hope you're clear. If you want, you can take that screenshot also. Really, that would be helpful. Then next one more idea. They have given two different points, but you see how we are going to give the name. Prefix mono, di, tri are used to indicate the number of individual ligands. You see, number of individual ligands in the coordination entity. Now this is the coordination entity. This is counter ion. This is what it is. Central metal ion, and this is ligand, coordination pair, all this. So this is called coordination entity. So individual ligands. Now how will you name this? Okay, come on. This is potassium. Potassium. There is a gap in between. And next what it is? Dicyanide. Dicyanide. Argentate. Small letter. Argentate. 1. So this is the way you will name this, di or tri or tetra poly, in that way, individual ligands. Suppose if they are asking in that way, when the names of the ligand with the numerical prefix, then the term it is bis, tris, tetrakis, they can be used in the ligand in the bracket. Okay, they have given one more example here, NiCl2 PPH3 twice. Now, how will you name this? Here in this dichlorido bis triphenyl phosphine nickelate 2. Okay, come on, let us write this. Dichlorido, no caps, right? No space also. Okay, dichlorido, chlorido bis, and here what it is? Triphenyl, triphenyl, and what it is? Triphenyl phosphine, phosphine, triphenyl phosphine nickelate. Close the bracket. Nickelate. Nickelate 2. Okay. So, these Roman letter and all oxidation state. It meant for oxidation state. Anyway, we can go and identify how to find out the oxidation state in that next one. Okay. Hope you got a clear idea. When the names of the ligand with the numerical prefix, then the term it is bis, tris, tetrak is like that. See, in the bracket only it has mentioned, and they have given used in the ligand in the bracket. Okay, now next one. If the complex ion in an anion, the name of the metal ion end with what it is? Suffix ate. Okay, now the complex ion is an anion. Now, for example, you see potassium here in that what it is, coordination pair, in that cobalt it is there, central metal ion, oxalate ion it is there, amine, that is ammonia compound is there. Okay, now how will you give the name for it? Here potassium, there is no caps, gap must be there. Okay, now here diamine, amine A and dioxalato. See, tri and all, let it be as it is. We are not giving priority for that di or tri or tetra. We are not giving priority for alphabetical order. Only we are giving what it is preference for the alphabetical order of ligands only. Okay, so that means amine oxalato. So which one will come first? Of course, amine. So diamine, there should be a gap in that. Okay, potassium diamine, double M, diamine. Suppose NH2 minus comes, means amine, AMI, amido will come. Okay, so here what it is, amine, diamine, dioxalato, there is no gap. Dioxalato, dioxalato, copaltate. Yes, suffix with ate, right? Copaltate. Called PATE. Okay. Okay, so this is the way you have to give the name for it. See now, the complex ion in an anionic complexes. The name of the metal ion end with suffix. So that this is a metal ion or central metal ion. So that it will be copaltate. Suppose if it is cationic complexes, same name it will be there. Now, for example, FeCO 5 times. So what it is, already I mentioned, you know this one, pentacarbonyl ion. That's all. Hope you're clear with that. Okay, now we got the rules of it. Now we are going to see the naming ceremony, how to give the name for it, each and every compound. Okay, come on, let us go for it. Anionic complexes, we will take it stepwise naming coordination compound. Anionic complexes, K4FeCN6. You know, K for K, it is a counter ion. Fe, it is a central metal ion. Cn, ligand, and this is coordination number, and this is coordination sphere. You know very well coordination entity. Now we are going to see the name. How do we keep it? All rules we have gone through it. Very simple way, I just bring it to you. Number of ligand. How many number of ligands are there? 6. Okay, now name of the ligand, cyanido. Cyanido. Okay, and name of the ligand with number, of course, 6. 6 means what we can say, hexa. Okay, hexa cyanido. Cyanido. Okay, now the next one, this is anionic complexes only, no? So the central metal ion combined with anion, that means the suffix should be ate. Now that means the name of the metal ion, iron, ferrous, ferrate will come. What is it? Ferrate. Why it is ferrate? ATE, because it is combined with anionic complexes. If it is cationic complexes, naturally it will be same as it is, right? Okay, now oxidation state. Actually, oxidation state, it is 2. I'll tell you later how to identify the oxidation state. Now we'll go for the IUPAC name. Okay, now K4FeCN6, we got that idea from here. Okay, now this is what it is. Potassium hexa cyanido ferrate 2 complexes. Hope you got a clear idea about that. Okay, now we are going to see COCl NH3 5 times Cl2. Now coordination sphere, next to that Cl2 it is coming. Okay, now this is a cationic complexes. Now first and foremost, an identical ligand, what it is, how many number of identical ligand? 5. And the name of the ligand with the number of the ligand. Name of the ligand, it is amine. Ammonia, no? Amine. Double M will be coming, and chlorido, only one chlorine. So chlorido. Chlorido, there is no gap. And number of ligand, penta, no cats. Okay, now name of the metal ion. This metal ion combined with cationic complexes. So that means cationic complexes means what is this actually? Here same name will be coming. There is no change. So cobalt. Okay, now oxidation state 3. So how will you give the name for it? Pentamine chlorido, because alphabetical order A and C. Okay, pentamine chlorido cobalt 3 chloride. Okay, pentamine pentamine chlorido pentamine chlorido cobalt cobalt, there is no gap, 3 chloride. Hope you got a clear idea about the anionic complexes and cationic complexes. Now, let us go and watch that anionic complexes of some examples. Potassium dicyanido argentate 1. Okay, now this is ionic sphere, this is coordination sphere. Okay, now how to write it? There is no capital letter, and the second one, coordination sphere, whatever it is there, no, that has to be in one word, right? Come on, let us go. The potassium dicyanido argentate argentate 1, oxidation state. Now the second one, sodium dicyanido orate 1. Sodium here, you see, sodium, there should be a gap, dicyanido orate 1. The next one, potassium tetracyanido nickelate. Potassium, there should be a gap, no capital letter, and tetracyanido See, that alphabetical order only meant for the ligand, not for di, tri, tetra, poly. Okay. So, potassium tetracyanido nickelate. Nickelate 0. Right? Now, next one. Potassium hexafluoridoplatinate. Potassium, are you able to see this? Okay. Potassium hexafluorido platinate 4, oxidation state. Okay, now the next one, potassium trioxalato potassium trioxalato chromate 3, oxidation state. Hope you got a clear idea how to write that anionic complexes, what are the things first, second, and how to write it, ionic sphere and coordination sphere. Okay, we'll see some more examples. The next one, potassium amine trichlorido platinate 2. Okay, now you see 2 ligands are there. In that, we have to give the priority for alphabetical order. So, amine chlorido. Okay, now come on. Potassium amine double M, amine trichlorido platinate. Right? That next one, KMNO4. See, potassium tetraoxalato Manganate. Manganate. Manganate 7. Oxidation state. This is 2. Right, I forgot. Right. Yes, this is 2. Okay, now the next one. Potassium tetrachloridonickelate. Potassium tetrachlorido. Tetrachloridonickelate. Nickelate 4. Okay, now the next one. Potassium amine, we have to give the priority first, then we have to give the priority carbonate. Okay, potassium diamine dicarbonatochromate. Potassium diamine dicarbonato and chromate 3 oxidations 3. Okay, now I think you got a clear idea about it. Last one, can you do it on your own self? Okay, just pass that button and you write it whether it is correct or not, you check it. Okay, sodium, this is coordination sphere. Sodium pentacyanato nitrosyl ferrate. Sodium pentacyanato nitrosyl ferrate. Ferrate 3. I hope you got a correct answer. I hope you got a clear idea how to write the nomenclature of coordination complex compounds. And this oxidation state 27233. Next class we will check it how to write the oxidation state for each compound. And BBT theory, crystal field theory, Werner's theory, isomerism, and so many interesting points let us learn in the next class. Take care and please subscribe this channel so that you will get all the notification. Thanks for watching.